Okay, welcome, Kyle. This is the week 6 webinar. So we're halfway through, just to let you know. We've done a lot. We're not halfway through the points in the course, but we're definitely halfway through the time. So what we're planning on doing today is talking about confidence intervals. That's chapter 8 from the textbook. And this is the beginning of pretty much everything we're going to be doing from now on is going to be truly used all over the place in research, in articles, and news, kind of anywhere where they look at data, they use this stuff. So welcome, Amberly. Thanks for coming. We're just starting out. So confidence intervals is kind of our first main useful topic. I mean, it's fun to find probabilities. You know, neat to look to see what the chance of winning the lottery is, but honestly, that's not something that people do in research. But definitely confidence intervals are something people do, and they do it in a big way. So that's the plan today. We're going to be talking about confidence intervals for a single population mean and a single population proportion. We'll talk about the other thing that I've never really mentioned, and that is how do you decide on a good enough sample size? And we've talked already that if you have quantitative data, you need at least 30, or at least 31 actually. And if you have the yes-no kind of question, then we have to make sure that the number of yeses and the number of no's are both bigger than 5. But that was to use the normal distribution. We're actually going to be doing something more useful, and not just how many you need to use the normal distribution, but how many people do you need to survey so that you actually have good data that's useful. Okay, so not just so that we can do math, but so we can use it. And we'll talk about that also, and there's going to be 3 formulas, just to let you know. So what I recommend is you definitely start thinking about your little note card you get for the midterm, and these 3 formulas will be on it, and we'll talk about that. There's some other things you'll want to put on the midterm from before, but formula-wise, these are 3 biggies. So I'll also just talk a little bit about the project. The project is not due until June 17th, sorry. So we have a long time before the project, but I'm going to mention a few things about the project. We're not quite ready to understand all of it because it's on what's happening in the next couple weeks. So you got plenty of time, but time to put the bug in your ear, basically. So do you have any questions, Kyle or Amberly, before I get started on some confidence interval stuff?
No, just want to let you know, because I'm on the road right now, I actually don't have my calculator with me, so I'm only going to be able to observe.
Okay, well, you'll observe. I always show the calculator when we need it, so you'll be able to at least follow along and take notes. Every calculator is a little different, but most of the TIs are somewhat similar. So just to note, yours might look a little different than what mine looks like. And honestly, the one I'm using is it's a free trial version that expires in 27 days. I've let the college know they need to get me one. I have calculators, but the ones that sit on the computer, that's a whole different thing. I don't have anything from that. That's because they gave me a new computer, but they didn't put on a calculator. So if there's no questions, let me move on. And I want to pull up an article. Again, I like to use news articles. Kind of my favorite website to go to when it comes to news articles for this class is actually Gallup. And the reason is with Gallup, you can actually find out what they did. Instead of just read the article, you can actually read the article and get the information on how they arrived at what they've got. So let me share my desktop. And I'll do that in a second. Share screen. Go to it. That one. And one more thing. There we go. Okay, so this is a Gallup article. And this is something I've been looking at for many, many years. 10 years I've been talking about this, and everyone thought I was crazy 10 years ago. And now everyone gets it. So this is one of those I've been predicting for a very long time, and that is driverless cars. So you've all heard of them. Any of you guys seen a driverless car on the street? I haven't either. They're not in Tahoe yet. There's all kinds of issues with snow, but they'll eventually get here. So they did also, they have a little article, And it says, Americans expect driverless cars to be common in the next decade. Okay. And let me just read the story, highlight the first one. 58% say driverless cars will be common within 10 years. So what do you think? Raise your hand. You don't have to unmute if you don't want to. If you think driverless cars will be common in 10 years. So that means that you'll see a driverless car and you're not going to go, oh my God, look at that. It's like, oh yeah, another one. Do you think that's going to happen in 10 years? Okay. So 2 out of 3? I think so too, so 3 out of 4. So let's take a look at one thing is, does that mean, it says, a slim majority of Americans, 53%, believe fully automated driverless cars will be common in the United States within 10 years. Do you believe that? Do you believe that exactly 53% of all Americans believe that fully automated driverless cars will be commonly used in the United States within the next 10 years? Do you believe that exactly 53% of all Americans think this? What do you think? Okay. So one thing I know absolutely is that they did not survey every American. You know how I know absolutely they didn't?
They didn't call you.
Yeah, they never called me in. Yeah, my guess is they didn't call any of you either, right? I've actually never had anyone say, oh, they called me. So they didn't call everybody, that's for sure. They couldn't. There's 330 million people or so in the country. So good luck. There wouldn't be time to do that or money. So they don't really know that 53% believe that fully automated driverless cars will be commonly used in the United States within the next 10 years. They don't know that. They're saying it, but they don't know it. So my next question is not, do they know this, but do you think that it's likely that over 40% believe so? Do you think it's a little likely? Do you think it's extremely likely? Do you think it's kind of likely? What do you think?
You said over 40%?
Yeah.
Yeah, I think that's extremely likely.
Yeah, we're going to find out that that's extremely likely. And in fact, over the majority is going to be likely. And the definition of likely in news articles, anyone know what that is? What percent chance do you have to be likely for a news article?
50-50 what?
No, good try, 95%. Okay, and that was done in the 30s by the New York Times, a very long time ago. Nothing about mathematicians or anything, but the New York Times decided that way before any of us were born. Okay, but they've decided that for news articles, they want to make sure they're 95% likely. Okay, but then I said 40%, but then what percent can they be 95% likely about Americans believing in fully automated driverless cars? The center of that percent should be 53%. So is it, say, 43 to 63%? Is it 33 to 73%? Is it 52 to 54%? Does that make sense? So if you want to find out an interval at which you have a 95% likelihood of Americans thinking that driverless cars will be commonly used in the next 10 years, you have to delve deeper. Any questions on this idea? Okay, and this is what confidence intervals are all about. So I'm going to scroll down. This is why I like to use Gallup. For regular articles, that's all the information you're going to get for some articles. For Gallup, okay, and there's other sites also. You can go to their survey methods. And by the way, any published paper, not news article, but published paper in a journal will also have the information in the survey methods. That's kind of a requirement for published papers. So what they said is results of the Gallup poll are based on telephone interviews. Okay, so that's always a little worrisome. We're going to assume that's random, even though we all know that telephone interviews aren't perfect. With a random sample, whatever that really means, because I doubt it, of 1,503 adults. So that's 1,503 adults. Let me write that down. 1,503. And that's our sample size. Do you remember the letter you used for that? Because it's going to be helpful for the calculator. Can you remember? What's the letter that corresponds to 1503?
N?
Yeah, that's N. Okay, that's important because we're going to have to put things in a calculator, and that is the N that you put in. And then it says for results based on the total sample of national adults, the margin of sampling error, which we're going to check to see if they did it right, is plus or minus 3% percentage points. So that means you can go up or down 3%. And it says at the 95% confidence level. Okay, so if you go down 3% and up 3%, what's your range?
Six?
It's 6, but it goes from what to what?
From, what is it, 92 to 98?
Now, remember, that's for the confidence level, but that's not the confidence levels that we're talking about. They said that 53%, does that make sense?
Oh, 50. Oh, okay.
Of Americans believe that self-driving cars will be common. So now the range, if you go down 3% and up 3%, you go from 50% to 56%. Does that make sense? And that's the range at which they can be 95% confident. Okay, the 3% is how far from the middle, which is called the margin of error. The interval from 50% to 56% is called the confidence interval. Any questions on this? Any questions? Okay, so now we can interpret this. And now I'm going to share the paint so that I can type. So I can interpret this as follows. Well, way too big. We could say with 95% confidence, we can conclude that the percent of all Americans who think that driverless cars will be common within 10 years is between 50% and 56%. Okay? There's other ways of saying it. You could say that we could be 95% confident that between 50 and 56% of all Americans think driverless cars will be common within 10 years. That's the same thing. There's other ways of noting the same thing. Okay? From statistics, we understand what that means now to say we have 95% confidence. So in particular, let me draw a little picture. Okay, that's always a picture, isn't it? It's always the same picture. So we can say that our mean is 0.5. Sorry, 0.53. And then between 50%, which is 0.5, I think that's that. Just a minute. Got to click 0.5. And 0.56. That's here to here. That's 95%. So that's what's going on with the confidence interval. Because remember, we said that as long as our sample size is large enough, and by the way, it was 1,503, and if you multiply 1,503 times 0.53, you get a lot bigger than 5, right? And similarly, 47% of 1,503 is also much bigger than 5. So there's no problem with using the normal distribution. So then we can say that the probability of being between 0.5 and 0.6 is 95%. Any questions on that? Okay, that comes from prior chapters, and this is for the sample proportion. That's all part of that central limit theorem that we had last week. Have I lost you any yet on this? So let me write down kind of in words what this means. So remember, the sampling distribution is all the possible sample proportions you can get. Okay, so what we can say this is interpret the confidence level and what we can say is that if we surveyed many samples, actually many groups probably, because people, of 1,503 people, then each group would result in a different confidence interval. Right? Because if they asked a different 1,503 people, they're not going to get the same number. They're going to get a different percent, and they get a different confidence interval. So one of the things you look at is say, well, there is a proportion of all Americans who think that self-driving cars will be common, right? We don't know what it is, but there is one. So the question is it between 50% and 53%? And the answer is maybe. Does that make sense? So if we kept doing this over and over and over again, we'd be successful in capturing the population proportion 95% of the time. So we can say that if we surveyed group by group by group by group and got a confidence interval and a different confidence interval and a different confidence interval, and you looked at all those confidence intervals, some of those confidence intervals will be successful and capture the population proportion. Others will be unsuccessful and miss it. So we can say that 95% of these confidence intervals will contain the population proportion of all Americans who think that driverless cars will be common within the next 10 years. Any questions on this? Okay, I want to note something that's really important. I'm going to highlight it. And that is right here, all. So you don't do a confidence interval for the sample because you know the sample. What you don't know is the population. So what we're doing is we're providing a confidence interval for the population proportion, not the sample proportion. Is that clear? So that word all is important. If you don't put the word all, I take off points, just let you know on the midterm. Any questions on this? Okay. So notice this is interpreting the confidence level in red. In blue, it's interpret the confidence interval. Let me write that down. Would be a question. There's different ways of wording it, but just want to get you ready. So the blue is the answer to interpret the confidence interval. Also, what's the conclusion? That's another way of saying the same thing. In red is interpret the confidence level, or what does it mean to be 95% confident? That's another thing that it interprets. Any questions at all? Any questions at all on this idea of a confidence interval? All right, let's go to another example. Okay, I'd like to give you one good example that comes right from the news or somewhere like that. And that was definitely one that worked like that. And let's do another example. This one's going to be a little different, and it's going to take some math. Okay. Whoa. Something weird happened. I think it's too big. There we go. Interesting. Having trouble. Sorry. Let's get there. There we go. Okay, that should give us enough room. Got it. And I think I need to do, sorry about this. Okay, so you're interested in estimating the proportion of all businesses that have a budget line item to advertise online. Always an interesting thing. Okay, if you want to construct a 95% confidence interval with a margin of error of no more than plus or minus 4%, at least how many businesses must you survey? Okay, so let's do this first. And to do this, you need a formula. So this is defining the sample size. Okay, obviously you need NP and NQ to be greater than 5, but we're going to need a lot bigger than that to get a small margin of error. And you want a small margin of error. But the problem is you also don't want to have to survey too many people. So it's a trade-off. You survey more people, you get a small margin of error. If you don't have the resources and survey fewer, you get a larger margin of error. Okay, so if we want no more than 4%, then we got to figure out how many to survey. Any questions on the question? So the first thing is we need a formula. And let me write this down. And this is a formula when we don't have any idea of what the proportion is. And it goes as follows. And that is N is equal to 0.25 times P times, not P, times Z over E squared. Okay, where Z is going to be the Z on the normal distribution. E stands for error, margin of error. So the first thing we know for sure is the margin of error is given, and that's plus or minus 0.04. And note that we're squaring it, so we don't care about the negative. The plus or minus doesn't matter. So what we can say is certainly E is equal to 0.04. That's a piece. Any questions so far? For Z, what I do is I draw a picture. And you know what the picture always is in this class? There's only one picture, basically. We have a normal curve. Okay, and we're going to do the standard normal curve. So the mean is 0. Now, we want a 95% confidence. So that means that that area is 0.95. Is that clear? What's this area here on the left? What's that area there? You have to do a little bit of math, but nothing too hard.
Is it 0.025?
Exactly, exactly. Okay, and the way Kyle got it, I guess, is took 1 minus 0.95 and got 5% or 0.05, because the inside's 95%, the outside's 5%. But then the left-hand side's only half of that. Half of 5% is 2.5% or 0.025. Any questions on that? All right, we need Z. Because in the formula, it's got a Z. Is that clear? How do you get Z if you know the area to the left of Z? In your calculator, how do you get it? What function do you have to use?
Is it INV norm?
Exactly, inverse norm. Inverse norm, because when you're given an area and you want Z, it's inverse norm, and it's Z, which means it's standard, mean 0, standard deviation 1. So now let's go and do a new share and show the calculator. And let me clear what we used to have. I'm going to go to second distribution. Going to go to inverse norm. Enter. Depending on the calculator, it'll look different. So the area is 0.025. The mean is 0. The standard deviation is 1. And we hit paste. And enter. Okay. The negative doesn't really matter because we're squaring it. Notice 1.96 is a very good approximation with that 9.9. So 1.96. Any questions on that? Okay, so now let's go back. That one. So Z is 1.96. There's a bit of work to get, but we got it.
Sorry, I'm just trying to remember how we found that the standard deviation was 1.
When you see the letter Z, it means it's standard. And standard means mean 0, standard deviation 1.
Oh, okay. Thank you.
Yeah, so that's just part of what Z means.
Cool.
Okay, so now it's very basic calculator. I don't think I need to share my desktop to explain how to put those numbers in a calculator, but I'm going to stick them in anyway. 0.25 times, I'm actually not even using the fancy calculator, I'm using Google's thing. times 1.96 divided by 0.04 quantity squared, and you get about 600.25. Any questions on that? So if you get 600.25, we want to be a little more conservative because we want to have a smaller standard error. You always round up. So 601 is the answer. So let's write this out. So we have to survey 601 businesses. Any questions on that? Okay, so now what we want to do is answer some of the other questions. So this is, notice this is a find a sample size question. Let you know the formula n equals 0.25 z over e squared. That takes a little bit of algebra, which I don't really have time to do, but I'll let you play around with it if you want. Okay, part B is suppose you surveyed 600 businesses. So we didn't quite do 601, we did 600. And 340 of these businesses do have a budget line item, finding 95% confidence interval. So calculator work. I'm going to write this down. N equals 600. And we have X equals 340. And the confidence level is 95%. So I'm going to go to new share. Go back to my calculator. And I'm going to go to stat, tests, and we haven't really done much with this. We haven't done anything with tests, but I'll let you know the rest of the entire quarter, we're going to be doing that. This is the whole point of the rest of the quarter, is to go through all of these different tests for the next 6 weeks. And what we want, since it's a yes-no question, that means we're talking about proportions. We want a confidence interval, so we have an int. We only had one survey question, so it's one prop z int. And I hit enter. And it asks us to find x, and x was 340. Oops, let's try again. And n was 600. Confidence level is 0.595, which is standard. Okay. Sometimes you'll use a different confidence level, but more often than not, it's 95%. I hit it calculate. And there we have it. Not much to it, right? So we could be 95% confident that between 52.7% and 60.6% of all businesses have a budget line item to advertise online. Any questions on that? Any questions on how this confidence interval works? All right, so let me go back. Okay, I just did B and I did C. I found the interval and I interpreted it. Now let's look at D. Okay, for part D, is suppose you want to find a 90% confidence interval for the proportion of all female-led businesses. Okay, so now we're going to do a different study that have a line item to advertise online, and you want a margin of error of no more than 3% now. Using the data from part B as a preliminary estimate, at least how many female-led businesses must you survey? Okay, so now we're going to use the data from part B. And I don't know if you noticed in the calculator, but our preliminary, our estimate is 57%. Okay, that was p hat. If you take 340 divided by 600, you get about 57%. Okay, it's actually, I'm gonna say 56.67% is even better. Any questions so far? Okay, now we're gonna have a different formula, it turns out. So let me go and write down the formula. And that is N is equal to P times 1 minus P. Sometimes you'll call 1 minus PQ, by the way. We've seen that before. Times Z over E squared. Okay, notice the 0.25 is replaced by the P times 1 minus P. Do you see that? Okay. Now, just in case you like math, if you take P times 1 minus P times a constant, that's a parabola. And the vertex of the parabola is when P is 0.5. And if you take 0.5 times 0.5, there's your 0.25. That's where it comes from. So it has to do with that, just in case you like algebra. You don't have to do that, but it's always fun. Okay, but we need this formula. So now, for the preliminary estimate, let's see what we've got. Let me change the color so we can do it in a different color. How about light green? So now we have E is equal to 3%, so 0.03. And we have N, we don't know N yet. We have P is equal to, as I mentioned a minute ago, it was 0.5667. And we need to find N. Okay, to find N, we got to find Z first. So first thing, let me just remind you that we're not dealing with 95% anymore. Now we're dealing with 0.9, 90%. So no longer 0.025. What's the percent now?
0.5.
0.5. If there's 90% inside.
Sorry, 0.05.
Yeah, 0.05. If there's 90% inside, there's 10% outside. Half of that is 5%. Anyone lost on that little calculation? So that's 0.05. And by the way, you definitely don't want to miss a decimal place or it'll get way off as your answer. All right, so now we can go to INV norm of 0.05. And INV norm of 0.05 is, I'll let you kind of figure that out. You should get 1.645. Now, when I have these memorized because they're important. Let's see if you guys can do it. Did you get it? You'll get negative, but the negative doesn't matter because we're squaring it. Did you all get 1.645? Okay. So now we just plug in. P, you take 0.5667 times 1 minus 0.5667, and then times parentheses 1.645 divided by 0.03, n parentheses squared. Stick it in your calculator, which I'm going to do on my other screen, just because I can't do it in my head so well. I can do a little bit, but not that great. So we get 0.5667 times parentheses 1 minus 0.5667, and then times 1.645 divided by 0.03 quantity squared. And round up, always round up. And what do you get?
I have 7.3829.
Except there's no point,
Oh, okay.
right?
What did I do wrong?
Right? It's 738.29 or 0.3, and you round up to 739. Does that make sense? Hopefully you noticed that. So we're going to survey 739 people, or businesses. Any questions at all on this example? Any questions? All right. So this is kind of the first find the sample size question that we've seen in this class. And I don't know if you remember in the first week I said we're going to have to wait to see how to figure out what kind of sample size you need. And we're there. Because that's really important. When you're designing your study, you have to decide how many people you want to survey. Also note that we got big numbers here, like in the several hundreds. So that's why I'm not, for the projects, you're not going to be doing yes/no questions. Because to have a reasonable project, you're going to have to do several hundred people. And that's just too much work. And I don't want to do that to you. Whereas if you're doing questions for means that are quantitative questions, then you don't need quite as many people to ask. That makes it a lot easier. Any questions on this? Okay, let me erase this. Oops. And we'll start again. So let me grab another question. And I need a couple things. Okay, so here's the next question. You're interested in estimating the mean amount of time that Lake Tahoe Community College students spend on campus on days they go to campus. Okay, you know the distribution is normal. The result of a survey asking randomly selected students is shown below. Determine a 90% confidence interval. Any questions on that? Okay, what's the big difference between this one and the one we just did? You want to know the main difference? We're going to attack it a very different way because there's a main difference.
Is it because it's not standard normal? Or
No, the other one, the standard, that was for finding the sample size. For part A, find the confidence interval. You want to see the main difference? There's a main difference. Should I tell you? Okay. The survey question is quantitative, right? The survey question is, how many hours did you spend on campus? And the person's not going to say yes or no. they're going to say, oh, I spent 6 hours on campus today. Is that clear? Okay. So it's quantitative, which means we're going to approach it differently. Okay. So the first thing we can do is jump right to our calculator. And I'm going to go share my calculator screen. There what we had. And what I'm going to do is I'm going to go to Stat, Edit, and I want to put my data into L1. So I go to L1, clear, and enter. And then just type in my data, 2.5, and then 3, 4, 2, 3.4, 5791, 1411, 4, 5, 6.5, 8.5. Any questions on that? Okay, then I'm going to go to Stat, Tests again. And we're going to think about what we need to do. Well, the first thing is we need a test. We need an interval, not a test. We want to find a confidence interval. So all these things that say test, that's next week. Okay, and the week after. So we're going to scroll down. And it's either going to be T interval, Z interval, or T interval. So let me tell you what's up with these. Z interval is using the normal distribution. Sounds good, doesn't it? There's an issue. The issue is that if we want to use a normal distribution, we need to tell it what the standard deviation is. And the problem is we don't know the standard deviation of the population. Is that clear? And because of that, there's extra error that occurs because we're going to use our sample standard deviation as an estimate for the population. And there's going to be some extra error. And this was found out mathematically a long time ago by actually a guy that worked for a brewery. And he was doing sampling on beer, and he realized that he wasn't getting it right 95% of the time. He was actually getting it right a little bit less of the time. And he happened to be a mathematician, and he realized that was the problem, was that he was using the normal distribution and just assuming the standard deviation was known, which it wasn't. So he came up with a new distribution. He was also a professor. He did both, professor and he worked for a beer company. And he named it after his students and called it the student's T distribution. So we're going to use the T interval. Any questions on that? And he used the T interval instead of a Z interval because we don't know the standard deviation of the population. So I hit enter. Now, if you look at it, it asks you data or stats. Do we have data or do we have statistics? What do we have?
Data.
We have data. So we enter on data. The list is L1. If it's not already in there, you go second one, and that'll put L1 in it. Freak, always let be 1. Can you remember that? In this class, we're going to always let the freak be 1. Okay, we wanted a 90% confidence interval, so we're going to go 0.9. Just to let you know, 95 is standard, but some places will use 90. I'll do some consulting from time to time, partly so I can kind of stay within the loop so I know what I'm talking about. And the Forest Service, they wanted 90%. And you know how it is. If you work for someone and they say something, the boss is always right. So I said, okay, we'll do 90%. Okay. So they didn't want the standard one, and they wanted 90%. So it's often whatever the boss says. But if you have a 90% confidence level, that means you're going to be less confident that your interval is going to contain the true population mean. Okay? But your interval will be narrower. It's a trade-off. So by being less confident, you can have a better interval. Okay, if we want to be more confident, then our interval is going to get wider. So for example, I could be 99.99% confident that the average height in America of people is between 3 inches and 1,000 inches. Right? But that's like, doesn't do anything for anybody because everyone already knows that. So if you want to be too confident, you're going to end up with such a wide interval that it doesn't really give you any new information. Okay, it just tells you what's obvious. Is that clear? So we had such a small sample size, we're not going to, if you try to let your confidence interval be too large, your confidence level to be too large, your interval is going to be really wide, like between 5 minutes and 28 hours a day, which is silly. Okay, does that make sense? So it's a trade-off. If you want your narrower interval, you have to have a larger level of confidence. There's only one way to get both a narrow interval and a large level of confidence. Anyone know what the way to do it is for a study? Any thoughts? A large sample size. So if you sampled, 1 million Americans, you could be 99.9% confident with a very small margin of error. Does that make sense? Because you have such a big sample size. Okay, but with a reasonable sample size, it's a real trade-off. All right, so then I just go to calculate. And there it is. It's about 4 to 7. Any questions on this? Any questions? All right. So I'm just going to call it 4 and 7. I'll round to the nearest whole number because it's easy enough. Then I'll remember it. And let me go back to the question. And we want to use a complete sentence. We just determined the confidence interval, 4 to 7. Now we need a complete sentence. So for part B, with 90% confidence, it can be concluded that the population mean number of hours that LTCC students spend on campus on days that they do go to campus is between 4 hours and 7 hours, or 4 and 7 hours. Any questions on that? Okay, I just want to highlight and note population mean. If that's not there, I take off points. Got it? Okay, it's not about the sample, it's about the population, this confidence interval. Okay, let's interpret the confidence level very similar to the proportion one, except it won't have the word proportion or percent. So let's interpret the level, and there we go. Let's try one more time. And what we could say is that if many studies, okay, or many samples of, and how many we have? 15, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, yeah, 15. Of 15 LTCC students were taken, then each would produce its own confidence interval. 90% of these confidence intervals will contain the population mean time that LTCC students spend on campus on days that they are on campus. Any questions on that? Any questions? If I lost you, just want to make sure, again, this is the time to ask questions. All right. Had the distribution not been normal? So in other words, we had to suppose you know the distribution is normal. What if we took that sentence out? We had no idea what the distribution was. Okay. Would the confidence interval still have been valid? What do you think? So what do you think? Kyle, Dominique, Zard, Robert? What do you think? Would the confidence interval still been valid? You still say 95% confident that it's between 4 and 7 hours. Could you say that had we not written that the distribution was normal?
I don't think so.
The answer is no. And what's the important number here?
15?
Yeah, 15. And in particular, 15 is less than 31.
Less than 31, yeah, okay.
Yeah.
I was doubting myself there. But.
No, you don't need to doubt yourself. Notice if it was a yes/no question, you got to do NP and NQ. But this is a quantitative, so you do 31. Right? Do you remember that? Again, don't get him. Always look to see is it quantitative or yes/no. Yes/no, you got to have NP and NQ greater than 5. And with a quantitative, you have to have n greater than 30. So since n equals 15, which is certainly less than 31, you could also write less than or equal to 30. The normality assumption was necessary. Any questions at all on part 2? Kyle, I muted you because you have a lot of background noise, but that's okay. But you can always unmute yourself if you have a question. Any questions on that? Okay, so let's do another one. And this will be the last one of the day. Let me just move this one down. And you know what I forgot? I got to erase this one first. Okay, suppose you want to construct a 90% confidence interval for the mean number of spam emails that come in daily per account and want a margin of error of no more than plus or minus 0.8. Spam emails. If you know the standard deviation is 14, how many email accounts must you monitor? Okay, so to do this, you need the formula. And let me get you the formula. So notice this is another sample size question. It's what the sample size you're going to need to be able to get a good estimate. So n is equal to And it's going to be sigma times Z over E squared. Any questions on that? All right. So now we know sigma. What's sigma?
14.
14. Okay, 14. And just a note, in the real world, if you don't know sigma, what you often do is you look at the range that you would guess that might be true. You might look at a few examples, and you might see the range tends to be somewhere between, 10 and 30 spam emails. Divide that range by 4, and that gives you a good estimate for sigma. Okay, kind of a standard range divided by 4 is typical estimate. Okay, it's not perfect, but if you don't know sigma, because you don't truly know exactly sigma, but you can estimate it sometimes. That's the real world stuff. Okay, E is given. What's E?
0.8.
Yeah, 0.8. The plus or minus doesn't matter because you're squaring it. Z, we've done it already, but I want to show you because this is usually the hard part for most people, is to find Z. We know we have a 90%. So that's 0.9. So do you remember what percent is to the left?
0.05.
0.05. Okay. By the way, on tests, I usually give some kind of strange percent so that it makes you do this picture. So don't memorize like the most common numbers. Instead, understand how the picture works. Is that clear? So I could give you, what is a 72% confidence interval? Okay, and you could do the same thing. You take 0.72, subtract from 1, you would get 0.28, divide by 2, and you get 0.14. So it's always the same kind of arithmetic. And then you use your calculator and you find the inverse norm of 0.05, and you get 1.645. Any questions on that? And then plug it in. Why don't you give it a shot? I'll plug it in also in my calculator. Let's see what y'all get.
Do you round to the nearest whole number for these?
You always round up.
Okay.
Yeah, you always round up for sample sizes because it's a little more conservative to do one more person or one more spam email account. Do you see that?
Mm-hmm.
And it's always good to have a lower margin of error. And it usually doesn't hurt to have one more that you're looking at least for our class. And then I'll tell you real life. What do you get?
829.
Good. 829 is what I got also. Okay. So you research 829 spam email accounts. Any questions on that? Should I tell you what happens in the real world? In the real world, it's a lot of work and one person can't do it. So you hire a group of people to do it, right? So let's say, you hire 10 people to do it. Then you have everyone do, say, 100. And that way you get 1,000. But if you've ever been a manager, What ends up happening if you hire 10 people to do work? Kind of reality-wise. There's always someone that flakes out. Isn't that true? So in the real world, you go way up because you expect someone to flake out when you have a team. Okay, and if you don't know that, you will learn as you get older. Okay, if you ever do management stuff or work with groups of people. And some of you have already experienced it with your projects. Okay, most of you had great teams, but some of you had to work with a project that didn't work as hard as that you would have liked to have them work. And we've seen some of that in the project discussion, on the discussion assignment last week. Okay, and that happens every time. So that's just a little psychology management thing, that's just how things really work. Any questions at all? Any questions at all on this example? Okay, I think what I want to do is I want to give you the secret word, and then I'm going to talk about the project for a short time. I want to do it with blue and bigger. And the secret word is not a word. Secret word is a number. And it is 95. Because that's one of the important things that we have, is that 95% confidence is kind of the standard confidence level. So it's a good one to remember. I always try and let the secret word be something that's important. Okay, any questions on confidence intervals before I spend a little bit of time talking about the project? Just a little bit. Okay, so secret word is 95. I'm going to erase it and everything else. And I want to remind you that the project due date, actually, let me write project 2 due date. One already happened. Anyone know what it is? It's in June. June 17th. Okay, it's on the syllabus. So the project due date is June 17th. You got a long time, but I noticed that in a lot of your discussion posts from last week, there were several of you that said you wish you got an earlier start. So it's really early now. You're not quite ready to start truly working on it, but you can start thinking about it. Because really next week we're going to do hypothesis testing, and that's going to be a big piece of the project. And the week after we'll do 2 sample, and that's what the project's really about. So the project is really about what's going to happen in 2 weeks from today. Okay? Okay, and actually I think it'll be 2 weeks from tomorrow, because 2 weeks from today is Memorial Day. And I try not to have webinars on holidays. Okay, so what should you be doing now? What should you make sure of? Just doing timeline. What should you make sure of now? That you have a partner. Okay, do you have a partner? If you don't have a partner, you should get a partner. And there's already one person that posted on the Project 2 discussion board saying, I need a partner. And I noticed that there were a few people from last week's post saying that they wish they had a partner. So maybe those people can get together and become a partnership of 3 or something like that. So that's the first thing. The other thing you should do is you should contact the partner. If you like your partner from Project 1, you don't have to have the same partnerships or partners. Contact that person or people and make sure that they still want to work with you. And they still want to, and that they're still in the class, for one thing. We lost a couple. We haven't lost too many, but we did lose a few students. And that tends to happen, especially in the online classes. A lot of students have trouble with time management, and they don't make it through. It's not that I don't think it's the class is too hard. It's just that they get behind and then they have motivation issues. That's, I think, that number one reason. So we did lose a couple, but not as many as I've lost in the past. A little more than we lost last quarter. Not too bad. So check to make sure you have your partner. Then I recommend, if the due date is on the 17th, that's a Sunday, by the way, then when should you give me the rough draft?
The 13th?
What's that?
The 13th?
Yeah, the 13th. Okay, or earlier, but definitely by the 13th. After that, I may not read it because there won't be enough time for you to actually handle all the stuff. And there may not time. That's a Wednesday. You get to me Wednesday. Thursday is my day that I can really work with online students. Friday, I tend to teach all day. And after that, it's too late. So by the time I can get back to you, if you give it to me on Thursday night, I won't have time to get back to you on Friday because I'm teaching all day. And then it's too late for you to do anything. So that's why I asked Wednesday. Okay. If you want to give it to me earlier, that's fine too. Okay. All right. The next thing, and this is kind of unclear the date, but project idea. Just a minute. That's better. Posted. Do you remember for project 1, I asked you guys to post your idea for the project so that I can help you and tell you whether it would work or not? Same thing for project 2. I recommend at least 2 weeks before the rough draft to have your just idea. So does that make sense? Okay. I don't know if that's perfect for you, but that's my recommendation. Again, these are all just recommendations. I can't force you to do anything. And that is the 30th. I'm just looking at a calendar. Okay. So again, you could do that. You could do it earlier. It's a little too early now to have your project idea because you don't really understand the content of the project. There's some stuff we have to do next week before you can understand it, at least mostly, and then the week after you'll understand it fully. This week you'll understand a tiny bit. Any guess on one of the main points of the project is going to be? Think today, that's a hint.
Confidence intervals?
Confidence interval. So you're going to be doing confidence intervals. It turns out you're going to do a confidence interval we have not done today. And that is the 2-sample interval. The 2-SAMP t-test. Okay? Or something called paired data test. So there's going to be a couple choices. It's a little early because you don't know what those things are. But you're going to be finding a confidence interval, and you're going to be doing a comparison study. So you're going to compare either one group to another group, or a person's attribute to a person's other attribute. Does that make sense? This is also very different than Project 1 in that Project 1 was a main point of it was understanding sampling technique. Do you remember that? This project, I don't care. You can use convenience sampling on this project. As long as you admit to it, that's fine. You won't lose points. You just admit to it and talk about how things could have been better and what you would have done to make it better. And that you'll get full credit if you do that well. Does that make sense? The other thing you can do, which you weren't allowed to do in the last project, is you can collect data not by survey. You can collect data by collecting data. So for example, I'm not sure, any of you from Tahoe? Okay. So one of you? Okay, so this Saturday morning at LTCC, do you know what's happening? 9 in the morning.
Snapchat Day.
Snapshot Day. Are you going to be there?
Yes.
Okay, I will see you there. Do you know what you're doing at Snapshot Day?
Oh, me? Yeah.
What are you doing?
We collect samples of water.
Collect data.
Yes.
Guess what? That's perfect for our class. Okay, so if you want, you have to convince your partner that they want to do it too. You could say, use that data for your project. Does that make sense?
Yes.
or use everybody's data, you know what I mean, in Snapshot Day. I'll be there too. So that's the kind of thing, whereas Project 1, you had to do a survey where you asked people questions. In Project 2, you just have to collect data. And that data could be collected by other people or collected by you, but it needs to be some kind of data. And you can do a comparison between something. It could be this year versus last year, for example. It could be this stream versus this other stream. So there's lots of different data collections you can do. Okay, does that make sense? It can be a survey too, if you want, of people, but it doesn't have to be. So it's very different. Don't make this Project 1. But it has to be a comparison study. Okay, that's the main stuff. I don't have enough, you don't have enough information yet to understand the details. Because if I say hypothesis testing, which is a main part of this project, you don't know what that is yet. That's next week. But each week I want to kind of get you a little excited about what this project is going to do. And I really want you to do something that interests you. Okay, don't do some silly thing. Do something that's like truly interesting in your field, or in kind of science, because you collected the data for Snapshot Day, or whatever you're doing. Okay, if you're working in a farm in Modesto, you can look at, I don't know anything about farming, but you could look at, what happens if you have a drip line versus a sprinkler system in terms of your crops. Those are the kind of things you can do. It doesn't have to be asking people. Does that make sense? So whatever it is that you are interested in studying, you and your partner, by the way, or partners. And same thing, 2 or 3 per partnership. So that's what Project 2 is going to be about. And each week I'm going to give you more information, the next week and the week after, until you'll completely understand what Project 2 is about. But I want to get you thinking about it now. Any questions? So we're pretty much done with what I wanted to say in this webinar, but I'm always happy to answer any questions you might have. And as always, if you don't have questions, we can say goodnight. It's still light.
I have a question about the midterm.
Okay.
How long do you allow us for a time?
That's a good question. 2 hours.
Okay, because I just made an appointment today for the 29th.
Okay. Yeah, the 29th is perfect. Good. So pretty much everyone takes it the 28th, 29th, or 30th.
28th, they don't have any availability.
29th is fine. 29th is fine. I'm just saying 29th is great.
It's Memorial Day on Monday.
Oh, that's Memorial Day, isn't it? Okay, yeah. Sorry about that. That's one of the things about, calendars, because it's the right time in terms of content.
Yeah.
Okay. So you can take it earlier. So most people will probably take it the 29th and 30th because you'll have a hard time finding a proctor on the 28th.
Okay. And then what's the size of our notes that we can use?
An index card, 3x5 index card.
Okay, front and back?
Front and back.
Okay.
And you can put whatever you want on it. That's totally up to you. I don't need to look at it. I don't need to. Sometimes they'll send me a copy of it. I just don't even open that up. So whatever you want to put on the index card. Some things obviously you're going to put on the index card. The 3 formulas I gave today, put those on.
Okay.
Do you remember those formulas?
Yes, I have them all.
You don't want to memorize them, right?
I have like all these formulas.
Yeah, there aren't that many. We probably about 6 or 7 formulas total.
Just stuff I need to remember.
Yeah. Okay, but we got 3 more today, and that might be it for formulas. Lots of definitions and stuff are coming, but for formulas, that's it. And just note, you need to let me know like a week before you take it. Please don't send it during Memorial Day weekend. One thing, I have a feeling I'm going to be backpacking that weekend, which means that I'm going to be offline. So if you send me anything on, Memorial Day weekend, there's a decent chance I won't see it until Monday night. Okay, I haven't made all my plans yet. Last year I told students if they could find me, they'd get an A in the class. Good luck.
Where's Waldo?
Yeah, I'm somewhere in the wilderness in America. Not on a trail even.
Larry, I'm going to say goodnight and hit the road. Thank you very much.
All right, well, have a good night.
You too. Thanks.
And if you have any more questions, that question that Amberly that you asked was a really good one. It's time to start thinking about the midterm. I'm glad you got an appointment already. Any other questions? Okay, good night.
Good night.
Night.
Good night. Any last questions? No? Okay, for all of you watching this as an archived webinar, thanks for watching. Please post on the Q&A forum if you have any questions about the midterm or about this stuff on confidence intervals or anything else except discussion, except for the project at which you want to post on the project 2 discussion forum. And have a wonderful night.